An instruction pipeline takes X cycles to execute n number of instructions without any hazard. And with hazard, the same n instructions are executed in Y clock cycles. This hazard is a branching hazard in which each branch instruction causes 2 stall cycles. There are 54 branch instructions among n, which is 200 total instructions, and the value of y is 312. Then what is the number of segments in the pipeline? So let us assume that there are s number of segments in the pipeline. So if there are n instructions, then if assuming that there was no hazard, so there is no hazard in the pipeline, so how many clock cycles would be required for n instructions? We know that the first instruction would require s clock cycles, which is equal to the number of stages, and the remaining n minus 1 instructions would require 1 clock cycle each to be completed. That means they would require a total of s, but every clock cycle one of them would be completed. So the total number of clock cycles without hazard would be s plus n minus 1, and it is given that n is 200, so s plus 199, and this is the number of clock cycles required if there is no hazard. And if there was a hazard, then the number of clock cycles that are required, which is y, and y is given as 312, that would be s plus 199, which is the number of cycles without the hazard, plus the extra cycles caused by the hazard. So there are 54 branch instructions which are causing these 2 extra stall cycles. So these many extra cycles would be required. So if we solve this equation, this one, and it is also given to us that y is 312, so we have to compute s, and if we solve this equation, we get s is equal to 5. So that means that there are 5 number of segments or stages in this pipeline.